Suppose you wanted to find the amount of data between two data values. To find the amount of data between two data values, because suppose you wanted to find it between this data value and this data value here. You wanted to figure out the amount of data, the area of this shaded region. To do that, you'd find the z-score of the first one, find the area to the left of that from table A, then find the z-score of the second one, find the amount of data from table A to the left of that, subtract those two values. Since you know your area has to be the positive one, it's always the larger value minus the smaller value. So suppose we want to be concerned about partial qualifiers. Partial qualifiers end up having a SAT score of a 720 and greater than a 720 but less than an 820. So in other words, we're wondering what percent of students fall in this category. Those students can actually practice, but they can't actually participate yet until they get good grades. So we'd already done the 820, so we don't really have to do that. Because we know the area to the left of the 820, we had figured out on a couple of slides ago is this. But we got to figure out the area to the left of the 720. So we're going to do a z-score for our 720. We still have our same mean and standard deviation, so we plug those values into our z-score formula. And so we end up getting negative 306 over 209. But since our z-score deals with decimals, we divide that out and we get a negative 4 or 1.46. So we need to find a z-score negative 1.46. So on our z-score chart, we're going to go to negative 1.4 on the left, find that row, mark that row, then our hundredths digit is a 6, so you got to go to a 0, 6 going across the top, go down that column. When you go to your z-score row of negative 1.4, down the column of a 0.06, you end up getting this one right here, 0.0721. So the area to the left of your 820 is a 0.1611. Area to the left of your 720 is a 0.0721. We want to know what's in between, so all we have to do is just subtract those two. It ends up being extremely close to 9%. So about 9% of all the students that take the SAT have scores that are partial qualifiers. Now, the cool thing about z-scores is you've been told in the past you cannot compare apples and oranges. But with z-scores, when you standardize everything, you can really compare apples and oranges, or grapefruit and peaches. So that's the cool thing about z-scores, is when you standardize everything, just writing it as how many standard deviations you are above and or below the mean, you can then compare your results, even if they have different units of measure. So suppose we wanted to take a look at preemie babies. Well, doctors and mothers don't like to have preemie babies unless they have to. So a preemie baby is anyone that is born less than 8 months, about 240 days since conception. Now, the doctors know that vitamins help improve the chances of making it to at least 8 months. The question is, does adding a better diet along with the vitamins increase your chances of not having a preemie baby, of making it to that 8-month window? Well, here we have some data. The blue data, bluish green, is our data that we have on women who just increased their vitamins. The mean is 250, standard deviation of 20. So those that had just vitamins, the average date from conception that they gave birth was 250 days. Well, when you're dealing with vitamins and better food, the average date that they gave birth was 266 days from conception. with a standard deviation of 15. That's the orange. You'll notice at 240 here, we have more the bluish green than we do the orange, which we have more preemie babies being born with just the bluish green, just the vitamins. But let's go ahead and look at the raw numbers on that. 240 is our cutoff date for when it's considered a preemie baby or not. Here's our mean and our standard deviation for the vitamins only. So we work out our z-score, taking our data value minus our mean over our standard deviation, getting our decimal. Then we want to go to our standard normal table. We want to go ahead and find a negative 0.05 on the left-hand column or left-hand side. Find that row, then you want to go ahead to your point 0, and this is in the 0 column, 0, 0 column, come down, and you end up seeing that 0.3085 is this area, or about 30.85% of the women would be expected to have a shorter pregnancy than 240 days. So about 31% of the women would have preemie babies if they just increased their vitamins and did nothing to affect their diet. So let's take a look at it, what it is for vitamins in food. We're still dealing with that 240 because that's the cutoff date for when you are at a preemie baby or not. Here's your mean. Just a second here. Had a typo there. Sorry about that. Here's your mean of 266, standard deviation of 15. And we'll go ahead and we'll plug that in. Our mean is taken away from our data value over your standard deviation. Go ahead and divide. This is your z-score. We need to go ahead and find that on our z-score chart, our table A, or our standard normal curve. So you need to go to a negative 1.7 on the left-hand side. Go all the way over to the column that's a 0, 3, because you have a 3 in the 100 spot. And you end up finding that you have a 0.0418, about 4%. So with vitamins and better food, only 4% of the women had preemie babies. So the results is that 4% of the women with better food and vitamins had preemie babies, where 31% with just better vitamins. In other words, the food helps because we're trying to have fewer preemie babies. So go ahead and look at these two questions and answer them. Okay, the answer for the first one is C. Remember, since you're looking for greater than, exceeding, you got to go 1 minus what you got from your table. You do your z-score with these values, look on your table, go 1 minus. For this next one here, as we look at it, since you're looking for the data value between these two, you need to figure out your z-score for the 490, your z-score for the 590, go to your table for your what you got from the 490, figure that out, go to your table for the z-score that you got from your 590, and subtract those two numbers from the middle of your table. Do not subtract the z-scores themselves, only subtract what you got from your table, and you get table A, or answer A. And let's take a look at one more here. We're just going to go ahead and do our z-score. Here's our mean, our standard deviation. Here's our data value. Since it's less than, we don't have to do anything special when we look at our table. We just go ahead and find our z-score and look at table A, and we get answer B.